Hey chemists, welcome to hydrogen bonding. It is the third and strongest type of intermolecular force that we will discuss. However, keep in mind that hydrogen bonding is the strongest of the intermolecular forces, but still much, 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 much weaker than a covalent bond that exists in water or exists in ammonia or exists in diamond. So, relatively speaking, the hydrogen bonding is weak, but if we're focusing on just intermolecular, it is the strongest. So, what do you need to know about hydrogen bonding? Well, first of all, this is my purple phase here of purple boxes. Let's remove that one. This is from your textbook. Hydrogen bonding occurs in polar molecules, and the big difference between whether you are going to decide on dipole-dipole or hydrogen bonding is whether or not hydrogen is bonded to nitrogen, oxygen, or fluorine, which are three of our most electronegative elements. All right, so repeat. If hydrogen isn't directly bonded to one of those three elements and the molecule's polar, then you're looking at dipole-dipole. If a molecule has present hydrogen bonding, it's also going to have London dispersion forces as well. So let's take a look at a few examples. These are right out of your textbook. HF. Fluorine, very electronegative. Hydrogen less so. Fluorine pulls those electrons from that, this is a covalent bond here, to fluorine, creates a permanent dipole. Hydrogen bonding is a permanent dipole. Let me write that down for you. Grab my pen here. Right here. Permanent dipole. Hydrogen bonding is a permanent dipole, if you can read that. And these bonds are pulled toward the HF. Permanent delta minus, permanent delta plus, and that happens in the next hydrogen fluoride molecule, the next hydrogen fluoride molecule. And what you have right here, here's your hydrogen bond between the fluoride of one molecule and the hydrogen of the next molecule. You'll notice that hydrogen is directly bonded to fluorine. That is the only way that you will have hydrogen bonding. Water. Water is also a molecule that undergoes hydrogen bonding. Once again, we have water. Water is a bent structure. We know that from determining our structures. Has a lone pair of electrons. If we draw our individual dipoles, we get this going to oxygen, this going to oxygen. And if we look at the net dipole goes up through the molecule. So that here is the delta minus overall of the molecule. Down here is the delta plus. But you'll notice that the hydrogen bond occurs between one hydrogen of one water molecule and the oxygen of another molecule. So there's where the hydrogen bonding occurs. Notice that hydrogen is directly bonded to oxygen. So what would a molecule that has hydrogen bonding with nitrogen? Okay, let me take away that third box first. And here's nitrogen. Okay. Lone pair, Nitrogen more electronegative, so electrons, again, if we look at the little individual dipoles, just to give us a sense of which way things are moving, they all go toward nitrogen. And then the net dipole, and it's not tremendously important that you know the net dipole, it just gives you a sense of the overall sort of polarity of the molecule, as that this is negative and this end is positive overall, which makes the molecule polar. But it is the hydrogen of one ammonia being attracted to the nitrogen of another molecule. And once again, the dashed purple lines here indicate hydrogen bonding. These are three classic examples of hydrogen bonding. Here we're comparing, go to this, here we're comparing very similar molecules. They all begin with water, hydrogen sulfide, hydrogen selenide, hydrogen telluride. And we notice that this is the only one in which hydrogen is bonded directly to oxygen. And remember, the three elements in which hydrogen must be bonded to in order for hydrogen bonding to arise are these three. Sulfur, no. Selenium, no. Tellurium, no. And you'll notice the dramatic boiling point of water with respect to similar molecules, only differing in the fact that they aren't one of these three, and the graph is showing you that right here. Okay? Doesn't have anything to do with molecular mass, has to do with whether or not hydrogen is bonded to oxygen, nitrogen, or fluorine. Okay? Stop the video here and see if you can determine whether or not which one of these molecules has hydrogen bonding and which one of these molecules does not have hydrogen bonding, they are all polar molecules. So here we have hydrogen bonding, and here we would have dipole, dipole. So stop the video, see if you can figure that out, and I'm going to do this right now. So if you want to test yourself, you can. Otherwise, you can just follow along with me. Water, we've just determined, is has hydrogen bonding. Here, hydrogen bonded, yes. Here, hydrogen bonded to nitrogen, yes. Hydrogen bonded to chlorine. Well, that is not RONF. So the answer is no. 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 Now the organic molecules are a little bit tricky, so let's bring this over here. Let's bring this over here. I'm going to just draw the skeleton. Well, maybe not. These are all hydrogens. I'm not going to draw them in. Here's the oxygen, and here's the hydrogen. This is ethanol. This is the stuff that people age 18 or older can imbibe in at the bar or any place they'd like. So, hydrogen bonded to oxygen. Yes, this belongs here. All right, how about this one? Well, I see some oxygens and hydrogens. Maybe I'd be here. Let's take a look at the structure. It turns out this is dimethyl ether. You'll learn about that later. I'm going to put in my hydrogens. Yeah, these are all hydrogens, but I'm going to put them in here. Is hydrogen directly bonded to oxygen? The answer is NO, no. So that is not hydrogen bonding. Let's take a look at this. It's called ethyl fluoride. Carbon, carbon, hydrogen, hydrogen, hydrogen. Okay, these are all hydrogens. Hydrogen, hydrogen, and the fluorine is here. No, not hydrogen bonding. And lastly, let's take a look at this. It's called ethylamine. And we will draw the structure, which is C, C, and again, hydrogen, 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 nitrogen, hydrogen, hydrogen, lone pair, which nitrogen likes. What do you think? Hydrogen bonded to nitrogen. That is a big yes. Okay, so this goes here. All right, that's hydrogen bonding. That's what you need to know. And I hope this has been helpful, and I will see you in the next video. And I will see you in the next video as soon as I learn how to turn this off. Bye, everyone.